So hello and welcome friends to our channel Intromec, and today we are going to discuss a little bit different topic, which is a CAD and FEA softwares which are available in the market. We all know that there are different kind of modeling and simulation softwares available in the market, and it is always difficult to choose a right one, but having a touch of any one of these softwares is always a icing on the cake. So this is the need of the future, so we should know that for which course we should go. So let's have an overview of these courses. Now we can split these available courses into two categories, like the CAD courses, which are also called as the modeling courses, and then we have the analysis courses. When I say CAD, it is computer aided design. That means we are designing with the help of computers. We have different softwares in which we can model the complex parts, then we can assemble them, and we can check the assembly even before the manufacturing. We can find out what will be the problems in the assembly and how we can tackle them even before the manufacturing. This saves a lot of cost, and it also gives us a chance for the flexible designing. Whatever you think in your mind, you can produce with the help of these softwares. So this is the strength of these CAD softwares. Now the second part, the second side of the coin, we can say, is the finite element analysis. Now simulation is a very important part for the product validation. We can say when I model something, it is necessary to validate that whether it is going to behave in the same manner that I am thinking. So that should be validated. Now it is not always possible to validate the model with the help of simple calculations. We have to go for the complex calculations. Now let's consider a simple example. If I have a complicated shape like this and I am pulling it from one side, say like this, I'm applying tensile load, and I want to find out the stresses which are getting generated into this body. Now whether it is possible to find out by mere calculations? No, we have to go for some rigorous mathematical calculations which will take a long time. Now if I divide this part, say, into small parts, and if I take a single part and I start analyzing this part, then it might reduce my time. Now this is nothing but the finite element analysis. I am splitting this body into small elements like finite elements, and I am analyzing these elements with the help of finite methods like differential methods, differential calculations, and all these calculations are performed by the computer. So these calculations are at a very fast rate, and we can simulate very complex designs. Now another advantage is we can simulate the physical phenomenon in the software. We can actually see that how my product will perform in the surrounding, what will be the different parameters, and according to that I can redesign my product. So this is the strength of finite element analysis. Now here you can see that there is a shaft which is like rotating. Now if I want to find out the torque, the shaft is getting twisted, right? So we can find out the different kind of stresses which are getting generated into this shaft with the help of finite element analysis. So this is the use of finite element analysis. Now let's go in some details. Now let's first consider the CAD softwares. Now there are n number of CAD softwares which are available in the market, and each one have their unique feature. Now I am going to focus on the most widely used CAD softwares. So if we see the market share of these softwares, at the leading position there is a SolidWorks, which has almost 22% of the market share. So it has around 22% of the market share. Then we have Fusion 360, which has around 6.7% of the market share. Fusion, then Rhino has 2.9, and then Katia and Solid Edge has a market share of 1%. So let's see what are these different softwares. Now the SolidWorks, which is the most widely used software, is designed by Dassault System, and it gives us a lot of features, and it is very user friendly. Now here I am not supporting a particular kind of software. I'm just giving you the overview of these softwares. Now the second one is the Fusion 360, which is developed by the Autodesk. Now all these modeling softwares are more and less are same, just the user interface is a little bit different. So you have to think like which softwares are widely used in the industry, because if you do the course of that software it should be useful. Then moving on, we have a Rhino, which is by Michael and Associates. Then we have NX by Siemens. Then Katia is by Dassault System, and this is a important software because most of the automobile surfacing and the seat design, all this type of design is done in the Katia software. And if you want to go into the automobile industry, you can pick this software and you can have a course of this software. Then Solid Edge is also one of the software which is given by Siemens. Now if you want to do the course of this softwares like certification courses, then there are different kind of courses available which offer you the certification, but you have to invest some kind of money into that. But if you want to learn the softwares by without investing any kind of money, then you can learn them on YouTube. There are a lot of modules available of each of these softwares and how you can download these softwares. Now the professional and the industrial licenses are costlier, we can't go for that, but each software offers a student version which is free. It has some limited features, but it is okay to start, and you can have a hands-on experience with this student version. Now each of these softwares have their student version, like here we can see. Now if you see Rhino, there is a Rhino student version. If you go on the site of the Rhino, you can get that. Then you have a Fusion 360 here, and one site is like get into PC. Now on this side, if you go for the 3D CAD models, and if you search different kind of softwares, here you can get a student or version, and they give the procedure also how to install the software. So this is also a useful site from which you can get the software. Now this is all about the different kind of CAD models. Now let's have a look on the FEA softwares. Now the FEA industry is very huge, and here also I am focusing on some of the leading FEA softwares like Ansys. Then we have Openform, then SimScale, COS Model, Autodesk CFD, and Altair Hyperworks. Now let's see one by one. Now, Ansys is one of the most widely used analysis tool because it offers a wide variety of different modules, and because of that it is very helpful. And when I say module, there are different kind of analysis. If you want to find out the stresses, you have to go for static structural module. Then if the body is in motion, you have to go for a dynamic module. Then there are rigid body simulations. If there is a heat transfer, then we have the thermal simulation. Then if there is a magnet, we have magnetic simulation. Then for the flow we have CFD. Then we have a coupled analysis in which we can couple the static and thermal or different kind of analysis together, which again gives us a huge variety and links us to the actual physical environment, so we can actually simulate the real world phenomena into this software. So here you can see like these gears are meshing, and when they mesh they have a contact. Now at the contact the stress is getting generated, and here we can see at each tooth we can find out what is the contact stress, and if the stress is higher we can redesign. So this is the strength. Now let's move on to the next software, which is Openform. Now Openform is basically a CFD, that is a computational fluid dynamic software. Now when I say CFD, it deals with the fluids. So wherever there is a fluid, you can have a CFD analysis. It has a huge application, let's say in gas industries, then turbo machines, rocket propulsions. Because there are gases, you have to find out what will be the thrust and other things, and it helps a lot. Now in this small video here, we can you can see that the blades are rotating and they're rotating into the air. So how the fluid is acting around it, so we can simulate that thing here. Moving on to the sim scale, this is again a CFD software, and is you can use it for different purposes. Now here you can see there is a Formula 1 car, and it is moving like in forward direction. Now for the such kind of applications, it is very important to find out what is the drag, because the main aim of this application, or main aim of the Formula 1 cars, is to have a less drag. Now just see, if we see the forces, like this is my thrust, this is my drag. Now my weight is acting like downward and upward is lift. Now here the drag force tries to retard my vehicle, and the lift force tries to lift the body upwards. Now when I say Formula 1 cars, the speed is most important, but when you move at a very fast rate, there is a drag, that is the resistance of air, which reduces your speed. So you have to reduce the drag, but when you reduce the drag the lift gets increased. Now if you reduce the drag and if the lift gets increased, then your vehicle may get topple. So this is a very crucial situation, and that's why we can simulate all this thing into say sim scale. And here you can see the air is moving at a very fast rate on this body, and we can find out the drag and lift forces, and according to that we can change the shape of this vehicle. We can have an aerodynamic shape, we can give the radius, and we can try a lot with these softwares because we don't have to invest into the actual prototyping. We can model this into say CAD softwares which we have seen earlier, say CATIA. Then we can import this into this analysis software and we can analyze all these things. So this is a very useful software. So let's move on to the next. Now this is a COS Model and it is a multi-physics simulation software and we can do lot many different things into this. Now here I have shown a example of electric motor simulation. Now there is a motor into there is a motor, let's say, in the electric vehicles, and the electric vehicle field is like booming. So uh, all the heart of this field is motor. So how we can design that? So here is the answer. In COS Model you can see how the flux density is varying, how we can change the number of poles, and how it will affect the different parameters that we can clearly see here. So this is the advantage of this software. Now next we have Autodesk CFD. Now again this software is basically into the fluid dynamics, and here you can see the application like my flow is going through this wall and I have to see that how it goes, the particles, how they are changing the direction, whether there is turbulence, or if there is turbulence, how it is affecting my pipe region. So all these things you can check out. You can vary the speed of the flow, you can check how it affects your flow path. So this is all about Autodesk CFD. Moving on, the last one is the Hyperworks, and it is a power of modern computing, we can say that, and it is very widely used in the industry. Here you can see that there is a sphere and the flow is getting diverted, and how the vertices are formed around the sphere we can observe here. So this is another example that how the flow is getting diverted and how is the pattern of this flow. So this is the alter Hyperworks. Now again, how you can get these softwares? Now Ansys has a student version and you can download it from their site. Then SimScale also have some free academic plan. You can see here they have some academic plan here, and from Ansys you can download the student software. Then again Cosmol also have some student plans, so you can go on the sites of the softwares and can have a student version. But all you need to think is the configuration of your laptops. Also just check out before downloading what is the configuration of your laptop and then download these softwares. So this is how all these softwares are important from mechanical point of view, and having touch with any one of these softwares is very important. So I just tried to give you an overview of all these softwares and I hope you liked my presentation. So if you have any doubts you can write that into the comment section and we can discuss over there. So stay home and stay happy. Thank you.